Hello there, welcome to part 2 as we continue talking about functions. This is where we left off, a whole bunch of writing. All that writing there was just from numbers 1 and 2, determining whether or not something is a function based on if the domain has two different output, if one domain has two ranges, two outputs. And so we looked at how to do it when you're given order pairs, and now we're going to look at what to do if you have a graph, and it's really easy, typically easier. I'm going to clean my screen off here just so I can describe 3 and 4 a little more clearly. And I don't really know how to take notes on this, other than I'll tell you this. If you have a little space down here left, when you have a graph on like 3 and 4, okay, so you can write this part down. For like 3 and 4, when you have a graph, when given a graph, that's given a graph, okay, non-functions have two y values for one x value. So that's what you're looking for. It's kind of re-describing what we did at the end of the last video there, determining if something is a function. All right, in other words, the easiest way to do it is called the vertical line test. And you basically just have to imagine this. Now I've printed a line here and I can move it around. See this line right here I'm moving across the screen? That's a vertical line. Okay, if this is a function, let's look at number 3. If this is a function, at no time will there be two values of x for the same, or one value of x that has two different y's. For example, I'm going to move it across, and I'm looking to observe where the line touches a point. Now there's one of my points. See it right there? That point right there? Okay. Well, that's okay because that x value only has one output. But look right here. When my line gets right here, you're going to see, if I get this vertical line to slide there, well, you can get the point here. Now it's being really sensitive for me. Okay. That line, when the line is right there, okay, what you have is you have, at that spot, you have two values of y for one x. Okay, so right there, you could write this on here. Those 2 points tell you that this is not a function. And you can basically stop right there. You don't have to continue because you've just proven this is not a function, because whatever this value is, here's the origin, right? 1, 2, 3. At x equal 3, you have two outputs. You have 1, 2, 3, 4. So you have the value 3, 4, and you have the value 3, 4, 5, 6, 7, 3, 7. So you have 2 points. So this is no. This is not a function. There. Now if I did the, so that's called the vertical line test. It's that simple. You're just looking to see if at any part are there two places where you have two outputs, two y values for one x value. Look at number 4. Okay, the blue line, that's the function. So as I slide this across, even though it's connected, at no time so far have I touched 2 points at the same time. Okay, that's the vertical line test. Okay, so because of that, you can say, yes, this is a function, because at no place is there two outputs for one domain. Okay, so that's how you answer the question, is something a function or not? All right, now moving on to the last part of our notes. So here's our function notation. Remember, that's just really the y, but we say f of x, if it's written like this, is equal to 6x minus 4. Find the value of each function. Okay, so here it says f of 3. Remember, that's f of 3. That's how you would say that. If I asked you to read that, you would say f of 3. So you're thinking f at 3 is equal to, so we replace the x with 3, so we replace that x with 3. Means 6 times 3 minus 4. And you see the math is nothing new to you at this point. That's 18 minus 4, and that's 14. So we say f of 3 equals 14. Okay, so there you have a value, and you'd have the order pair 3, 14 if we wanted to take it that far. All right, number 6, same idea. Say f of negative 5 is equal to, the function is 6 times negative 5 minus 4. So we do the math, work this out, negative 30 minus 4. So we would say f of negative 5 equals negative 34. How did I get negative 34? Boom, boom, negative 30 plus negative 4. F of negative 5 is equal to negative 34. F of 8, we'd say f of 8 equals 6 times 8 minus 4, 48 minus 4. We'd say f of 8 equals 44. And then the last one, so it's really pretty simple. And what I said at the beginning of the video, there's nothing really difficult about this other than understanding the new concept, but the concept is pretty simple. This f of 8, this notation, is nothing other than y equals there essentially for us. But in algebra, this notation actually becomes quite handy for us for reasons that you probably won't know for a while. So if I'm going to do the last one here, f of negative 9, that's negative 54 minus 4, boom, boom. Okay, f of negative 9 equals negative 58. And there you have it. Okay, so these are introductions to functions, and functions are the way we start to look at equations as we move on into some higher level math classes like algebra, trig, calculus, and those fun things like that. So get all those notes down and we'll talk more about it when I see you next.